Hey, welcome to Optics Lesson number 2, Production of Light. This is looking at where light actually comes from and how do we make it. Now, you'll remember, a luminous object is one that actually can create light. Now, the fancy excuse is, light's created by the motion of electrons in an atom between energy states. Basically, an electron drops, the energy gets turned into a photon, and that's what we see as light. Now, if you want to know in a lot more detail how that happens, take grade 12 physics. What we need to know for this class is, how does this actually happen in practical situations? And there are actually a few ways this can happen naturally. The first is called incandescence. Now, incandescent is that when things are heated, they emit light. Now, this is how the sun, why you see the sun. The sun is glowing, it's emitting light, it's very hot. The trouble is, using this as a way to produce visible light is extremely inefficient. So that incandescent light bulb you've got screwed in your house only converts about 5% of the energy to light. In fact, 95% is lost as heat. That's why if you touch them, they're really, really hot, and why they use a lot of electricity, and we're trying to get rid of them. So the example you see here is the usual incandescent light with a filament, but things like your elements in your oven and anything that glows when it's heated up is basically the same idea. It's incandescence. The second is what we call electric discharge. Now, what that is it's electrodes placed within a sealed tube with a very, very thin vapor of gas. And what happens is it creates light by giving energy to the electrons in the gas vapor. If you remember the diagram I had in the first slide, basically we're just doing it directly. The wavelengths of light released depend on the gas in the tube. Unfortunately, most of these release light in the ultraviolet, which tends to be not visible and give people sunburns, but we can fix that. The next is fluorescence. Now, fluorescence is the property of some chemicals that they emit light when they're excited. Now, fluorescent doesn't glow all the time. You actually have to shine light on it, and then it will re-emit it again quite quickly. Phosphorescence is a fluorescent material that will last for quite a few hours after you've exposed it to light. So if you have a fluorescent watch, and it seems to get fainter as the night goes on, that's because it's phosphorescent, and it's emitting the energy that it's stored. It's not actually creating new energy. By the way, fluorescent cats are actually coming. Now, what a fluorescent light isn't quite fluorescence, and it isn't quite gas discharge, it's a bit of both. So what happens is you have a gas discharge light, and it's covered with a fluorescent powder. So when the UV light produced in the gas discharge is created, it hits the fluorescent coating, gives it energy, and that's emitted then as visible light. Now, these devices are 4 times more efficient than incandescent bulbs. So they're a lot cheaper to use. Those are why, if you look up right now, we have neon lights in the school. They're also those weird, twisty, compact fluorescents. Now, those compact fluorescents are going to be going the way of the dodo pretty soon because of something called photoelectricity. Now, photoelectricity is a way to emit light using something called a semiconductor. These are electrical devices that convert light directly to electricity, so they're extremely efficient and long-lasting. You probably are looking at one right now in the LED on your computer or on the computer screen you're looking at. Now, why they're so effective is that they literally turn the electricity directly into light with no heat produced. In fact, they're so efficient that you could create thousands of watts of light plugged into just your normal, any everyday outlet. The other thing is, they're really great if you like HD because you can't do HD without photoelectricity because they don't flicker. And when we start doing really careful HD cameras and HD film, you would actually notice the flicker of incandescent or gas discharge lights. Chemiluminescence is kind of cool. It's chemical reactions that produce light. The most common you're probably used to is glow sticks. You crack them, they start glowing. They don't glow for very long. They only glow while the reaction's happening, because it's the reaction that produces light, not the chemicals. That's why it's different than fluorescence. The last is what I think is one of the coolest. It's bioluminescence. It's basically chemiluminescence that's done by a living organism. Good example is fireflies. Also, jellyfish and a lot of neat things in the ocean can do it as well. So, those are the main ways that we can actually produce light. The next step is, what do we do with the light once we produced it?